The rock beneath your feet is older than anything you can imagine. Not old like a cathedral. Not old like a dinosaur fossil. Old like the universe itself was young when it formed. And for most of human history, we had no idea. In 1650, an Irish archbishop named James Ussher calculated the age of the Earth using biblical genealogies. His answer: the Earth was created on the evening of October 22, 4004 BC. He was precise to the day. He was wrong by 4.5 billion years. The question of how old the Earth is turns out to be one of the greatest detective stories in the history of science. We cannot travel back in time. We cannot watch the Earth form. We have no receipt, no timestamp, no birth certificate. So how do we know? The first serious scientific attempts came in the 18th and 19th centuries. Geologists noticed something extraordinary. Rock layers, sediment laid down year by year in rivers and oceans, accumulated at measurable rates. By measuring how thick the layers were, they could estimate how long it took to form them. Charles Darwin estimated the Earth was at least 300 million years old. The physicist William Thomson, Lord Kelvin, calculated it differently. He assumed the Earth started as a molten ball and measured how fast it would cool. His answer: 20 to 40 million years. Confident. Authoritative. Wrong. Kelvin's calculation failed because he did not know about radioactivity. He assumed the Earth had no internal heat source. But it does. Radioactive elements deep inside the Earth are constantly decaying and releasing heat. The Earth is not just cooling, it is being continuously warmed from within. Kelvin's model had a missing variable that made his answer off by a factor of 100. The discovery of radioactivity in 1896 by Henry Becquerel changed everything. And this is where the story becomes genuinely elegant. If you remember the periodic table episode, radioactive elements like uranium and thorium have unstable nuclei. They decay, they break apart and transform into different elements. And here is the crucial property: they do this at a perfectly constant rate. This rate is called the half-life. The half-life of an element is the time it takes for exactly half of a sample to decay. Uranium-238 has a half-life of 4.47 billion years. Meaning if you start with 1 kilogram of uranium-238, after 4.47 billion years you will have exactly half a kilogram left. The other half will have transformed into lead-206. This constant rate of decay is a clock, a natural clock built into the atoms themselves. And crucially, it cannot be stopped, sped up, or slowed down. Heat does not affect it. Pressure does not affect it. Chemical reactions do not affect it. The decay rate is determined by nuclear physics alone. To read this clock, geologists find rocks containing uranium. They measure how much uranium remains and how much lead has accumulated. The ratio tells them how long the decay has been happening, which is how long since the rock solidified. This technique is called radiometric dating, and it works because of one elegant principle. When a rock solidifies from molten material, it resets the clock. Molten rock allows elements to move freely, so lead can escape, and only uranium remains. The moment the rock crystallizes, the lead produced by decay begins to accumulate and cannot escape. From that moment, the uranium-lead ratio starts changing at a known rate. Reading the ratio tells you when the rock solidified. In 1956, a geochemist named Claire Patterson performed the most precise radiometric dating calculation yet attempted. He measured the uranium and lead ratios in ancient meteorites, rocky debris left over from the formation of the solar system. His answer: 4.55 billion years. With an uncertainty of just 70 million years, less than 2% of the total age. That number has been refined but never overturned. The current accepted age of the Earth is 4.54 billion years, plus or minus 50 million. The calculation Patterson made in 1956 was correct. But the oldest rocks on Earth itself created a problem. The oldest continental rocks we have found are about 4.0 billion years old. And the Earth is 4.54 billion. So where are the first 500 million years of rock? Gone. The early Earth was a violent, molten, constantly bombarded place. The first rocks were destroyed, recycled, melted, and reformed. The geological record of the first 500 million years has been almost entirely erased. Almost entirely. In 1983, geologists found something extraordinary in the Jack Hills of Western Australia. Tiny crystals of a mineral called zircon. Zircon is exceptionally resistant to weathering, heat, and chemical alteration. It survives almost everything, and inside these zircon crystals, trapped like insects in amber, was the uranium lead ratio that told their age. 4.4 billion years old. The oldest material ever found on Earth's surface. Older than continents. Older than oceans. From a time when the planet was barely recognizable as the world we live on. You can hold a zircon crystal in your hand and be touching something that formed when the Earth was 140 million years old. When no life existed anywhere on the planet. When the Moon had just formed from a catastrophic collision. The crystal survived every geological upheaval of the last 4.4 billion years and ended up in your palm. The Moon provided independent confirmation. When Apollo astronauts brought lunar rocks back to Earth between 1969 and 1972, scientists radiometrically dated them. The oldest lunar rocks were 4.4 to 4.5 billion years old. Consistent with the meteorite data. Consistent with the zircon data. 3 completely independent lines of evidence, from 3 different types of material, all pointing to the same answer. 4.54 billion years. Not 6,000 years. Not 40 million years. 4.54 billion. And the method has been verified again and again. Different radioactive systems, potassium-argon, rubidium-strontium, samarium-neodymium, all produce consistent results when applied to the same rocks. The ages agree, the clocks agree, the physics works. There is a final remarkable piece to this story. The lead that Patterson measured in his meteorites did not come from uranium decay alone. Some of it was there from the very beginning. Primordial lead created in the supernovae that seeded the cloud of gas and dust that eventually became our solar system. Which means the atoms in those meteorites, and in the rocks beneath your feet, were forged in dying stars that exploded before our sun even existed. The iron in your blood, the calcium in your bones, the uranium ticking away in granite, all of it made in stellar explosions billions of years before Earth formed. Your planet is 4.54 billion years old. The atoms it is made of are older still. And we know this not through faith or calculation or guesswork, but through the patient reading of clocks that nature built into the atoms themselves. In the next episode, we go further back. Before the Earth, before the Sun, before any stars existed at all, to the first moments after the Big Bang, when the universe itself was just minutes old. If this changed how you see the ground beneath you, subscribe to Knowable. Drop a comment. What surprised you most? New science explainers every week. See you next time.